Hello! In this video, we're going to make a kind of real-time dynamic icon maker type thing. So basically the UI elements that you see when you look at an inventory in a game or when you have the toolbar across the bottom, these are the images that represent the items that you are carrying or whatever. I'll be honest, it's not going to be that useful for a game like 7 Days to Die or Rust, where the items are all sort of pre-made and, you know, they all exist as prefabs or as objects. You would go ahead and make your own icons for that. This is more for procedural things. So, for example, Minecraft, where you're making loads of different blocks, you might want to use this to do the inventory icon for the blocks. For something like Borderlands, where you've got randomly generated weapons, you might want to use it for that. But yeah, so that's what we're going to do in this video. So let's get started. So the first thing we need to do is we need a image that we're going to put our icons in. So I'm actually going to create two images. One of them is just going to be a background just so we can clearly see what we're doing, and I'm going to make this 125 by 125 and we're just going to stick it in the center. Doesn't really matter where it is because we're not making a proper game here. This is just to demonstrate it. Also, I'm going to turn this background to a solid color just so it's less distracting. There we go. Why not? We'll just call this BG. That's all it is. And then in there, we're going to create another image, and this one is going to be the one that we are going to put our icons in. So we'll just call this icon. And we're not going to give it a background image or anything, but we do want it to be 100 by 100. The size can be whatever you want. This tutorial is assuming that you want your icons to be square. There's not much to change if you want to make them not square, but just bear that in mind. So the next thing that we need is a camera. So the way that we're going to do this is we're going to have a second camera. This camera can exist in the world permanently. You can have it off somewhere in the distance out of the way of the game world, or you could just instantiate it when you need it, or there's other things you could do with it. But basically I'm just going to put it off the side in the game world, and that camera is basically we're gonna stick our item that we want an icon for in front of this camera, grab a screenshot of where it's showing, and then we're going to use that to make our icon. So the first thing we need for that is an actual camera. So if we just go down here and we create a camera, and we want to give it a depth that is less than the other camera. So the other camera I think is set to 0. So this camera wants to be set to -1. So that ensures that this camera doesn't show up above the other one, which we don't want. And the next thing, I'm going to shuffle it off to the side. So -500, I think. And Y wants to be 0, Z wants to be 0. We just want it to be something that we can easily drop in front of. You would probably make an instantiation position, because whatever items you get in an icon for, you're going to be putting them there in code procedurally. So usually you wouldn't be dropping it by hand here, because if you go into the trouble of dropping it into the scene and then using it to create an icon, you may as well just create the icon image. And like I say, this is more useful for if you're getting icons of procedural items, not items that already exist. So the next thing we want to do is we want to switch. Now we're going to leave Skybox on for this one for now. We will change that later, but for now, just so we can clearly see what's going on, we want to switch perspective to orthographic, and don't worry about the size for now. And then the final thing that we need is a prop. Knowing full well my audience and the type of videos that they are most interested in, I'm going to go ahead and assume that most people who use this code or follow this video or interested in this video are going to use it for some kind of Minecraft-ish type thing to get icons of your blocks. So with that in mind, I've gone ahead and found a asset pack that is basically some fancy blocks. So I have got a test block. I just grabbed a random block. This is a brick block of some kind. We're going to put it at -500. 0, and then we'll go with 10, doesn't really matter, and we can see our block there. Now it's quite off in the distance, but that doesn't matter, because with the camera, with an orthographic camera, you change that very easily by just changing the size. So we'll just leave the size there for now, but none of that's going to be relevant in the end because we're going to be setting the size in our code. But for now, let's make some code. So create a new script in our scripts folder, and I'm just going to call it Icon Maker for lack of a better, more imaginative name. So first off, we'll get a few necessary public values. So we need our image, which I believe we're going to need to include. Yeah. So we're going to need to include Unity engine.ui for that. I'm just going to call that icon, and then we need a public camera, which is cam. If we were using the main camera, we could have used main.camera and grabbed a reference to that, but we're not using the main camera, so we need to actually get it. We're going to create a new function, which is a sprite function, a function that returns a sprite. It's going to be called getIcon, once again, for lack of a more imaginative term. And it's showing an error because we're not returning anything now, but we will do. So the first thing we're going to do is get our dimensions. So the dimensions are the dimensions of the screen, which it could be anything. If you're playing on a 4K monitor, if you're playing windowed, if it could be different. So we need the dimensions of the actual screen. And we get those by saying screen.width and int res y equals screen.height. And then we want to initialize all of the parts. So the first part we're going to initialize is texture 2D. We're just going to call it text even. New texture 2D. Res X is the width. Res Y is the height. And then we want texture format dot RGB24 and then false. We don't need a bitmap. And then the next thing we need is a render texture. So a render texture, if you don't already know, I'm sure most of you do, a render texture is a texture that you can draw to with the camera, basically. So you can have the camera, instead of drawing to the screen, you can have it draw to this texture, and that's going to equal a new render texture, a height of the screen, or the width of the screen, the height of the screen, and the depth of 24, which is the highest, I believe. I think you can have 8, 16, 24, but I don't think it goes higher than 24. And then the next thing we're going to say is cam, so that's our camera. Target texture equals RT. So now we're telling the camera that we want it to draw to this texture instead of to the screen or whatever. And then we say render texture dot active equals RT, which is exactly what it sounds like. Here we're going to say cam dot render. So what we're doing there is basically telling the camera to render as opposed to waiting for it to do it at the time it would normally do it, which would some point in the loop after the late update, I think. I'm not sure exactly when it comes in the order, but we're telling it to do it now because we want it now. And it doesn't matter because we're not drawing to the screen, so it's not going to make anything look weird. So the next thing we're going to do is read pixels, which the read pixels command reads pixels from the render texture that we've created and puts them into this texture that we've created here. So as you may have guessed, these need to be the same size, or kind of, because what we're going to do is we're going to give it a rect, and this rect tells it the area of screen that we want to draw. So it's starting at 0, 0, and we're going to res X by res Y. And that basically just means it's grabbing the entire screen and putting it into this texture. The next two values are the position within text that we want to put it. So basically the origin point. So we're getting the whole screen. We're starting at 0, 0, and we're going to res X by res Y, which currently is the screen width and screen height. And we're putting it into text at 0, 0. And then after that, we just want to say text dot apply. And then we just need to do a little bit of cleanup. Cam dot target texture equals null. Render texture dot active equals null. Now for these ones, I'm trying to make this a self-contained function. For these ones, you could theoretically just have the render texture set up and left alone if you were going to be doing this a lot. But yeah, I'm trying to make this all self-contained. So we created this render texture in here, and we're going to uncreate it when we're done, and we're going to reset the other camera to not use it anymore. And we quote uncreate by destroying it. And the final step is to return our texture as a sprite. And once again, when we're returning it as a sprite, we need to give it a rectangle which represents which area of the texture we are returning as a sprite. And because we want the whole thing, then we're just going to pass in 0, 0 for the start position, and text.width and text.height for the end position. Now we could use res X and res Y for this part, but as you'll see later on, there is going to be a difference between the screen resolution and our final texture image, but we'll get to that shortly. And then the next one is the pivot point, which you can set this to whatever you want. It really doesn't matter for what we're doing, but yeah, if you wanted your pivot point to be in a certain position, you would do that there. So that's this function done so far. And then the next step is to in start, we're just going to say icon.sprite equals get icon, and that is that. Let's go back to here and drag in our necessary values in the inspector and see what it looks like. So I'm going to put my icon maker script on the canvas, just for lack of a better place to put it. We want the item camera, which I'm going to actually name item camera so that we know what we're dealing with. And then also we need our icon image. If we press play, we should see an image. There we go. So that's part of the way there. Although as you can see, it doesn't look very good because it's squashed. And the reason it's squashed is because we are looking at a 16:9 image here, screen. our game window is 16 by 9, and that means that the texture that is being grabbed by the render texture is also 16 by 9, but we're cramming it into a square image, which is no good. So we need to deal with that next. So the first thing we're going to do is we'll just change this to get cam.pixel width instead of screen, and then change this to get cam.pixel height. If we go back into here now and we click on our item camera, we can see here in this little window that we've got a representation of what the camera sees, and it is in that 16 by 9 format. If we go over to here, we've got our width and our height. If I change that, this is normalized by the way, so 1 is the full width and 0 is no width. If we change that to 0.5, I don't know if that's exactly right, but the ratio I mean, but that's roughly square. If we change that to 0.54-ish by 1, that gives us a kind of squarish image. It doesn't matter if it's not perfect because we're not going to be using this, because if I press play, you see it's off to one side. So what we need to do is we need to adjust for that, basically. So let's just switch that back before I forget. And the other thing we need to take into account is that we don't always know what size the screen's going to be, so we can't set that to 0.54, because what if someone's not playing in 16 by 9? And also, what if it's on a mobile device and it's playing in portrait mode? So we need to be able to account for all these things. So we're going to create some new values, and they're going to be called int clip x equals 0 and int clip y equals 0. And what these are going to be is the amount off of each value. So if we are dealing with a 1080p image, so 1920 by 1080, we want the 1920 image to be cropped down to 1080, which makes it square. The difference between 1920 and 1080 is 840, so we will be taking 840 off of 1920. But we need to work that part out, so our next step is to say if res x is greater than res y, which is another way of saying if resolution is in landscape, and then we're going to say clip x equals res x minus res y. Else, if res y is greater than res x, which is another way of saying if resolution is in portrait, as you probably guessed, we're just going to say clip y equals res y minus res x. And then else, we're not actually doing an else, but else, it's already square, so we've already got if one is bigger than the other and if the other one is bigger than the other. The only other state it can be is both are equal to each other, which means it's already square, which means we don't need to do any of this. So else leave values at 0. So now we need to factor these values in. So there's only two places we need to do this, and that is on this line here where we create our texture, and on this line here where we populate the pixels of that texture. So for this one, we want to say res x minus clip x, and then we want to say res y minus clip y. Now, if you remember, we're using this regardless whether or not it is landscape or portrait, but if it is, for example, landscape, then clip y will be 0. So whatever the resolution is minus 0 is just going to equal the resolution. And it's going to work that way for down here as well. If the value is 0, it's not going to change anything. So that means that we don't have to repeat any code for whether it's landscape or portrait. So that's convenient. So down here, this one's a little bit more complicated. So we want to say it's going to start at clip x divided by 2, because, and same for y, it's going to start at clip y divided by 2. And the reason for that is because we want it centered. Like the amount that we're clipping off the edges is, well, in the 1920 example, it was what, 840 or whatever. That's off the overall width, but we're not taking it all off of one side, because then the picture would be off to one side, wouldn't it? So we need to split it in half, and we need to take half of that 840, so 420. We need to take 420 off one side and 420 off the other side. So that's our start position, and then our end position needs to be minus clip x, and finally minus clip y. And now if we run that, you can see we've now got a square image, which is a lot nicer to look at. I've just realized we've got 2 listeners in this scene because I've left one on this camera here. We don't need that. Okay, so the next thing we're going to want is, right now we have all this sky in the background, which is not good. Like, you don't want sky in the back of your icon image, or maybe you do, that's entirely up to you, but assuming you don't, you want it to be transparent. Luckily, this is a very easy one to do. So all we need to do is go up to where we set our texture here, and all we want to do is change this to 32, and that's, oh, sorry, RGBA 32. So instead of red, green, blue 24-bit, we are doing red, green, blue alpha 32-bit. So that recognizes transparency now, but we need to tell it what is transparent, because if we press play now, you can see we've still got the sky, but that is because this doesn't count as transparent. We need the camera to ignore the sky and treat it like transparent. So if we go up to here and we click on depth only, nothing's going to change in the preview, but when we press play, you can see that we have a fully transparent icon thingamajigger. And if I drag that around, You can see it's not drawing any of the background. So, and also if we go over to our test block here and we just give it a bit of a rotation, because like I said, this is probably more useful for the Minecraft people. So let's give that a bit of rotation that way and a bit of rotation that way. Yeah, something like that. So if I press play now, you can see we've got the right perspective for like a Minecraft block. But as this is also helpfully pointed out, you can't see all of it now because it's out of bounds. So that brings us to our final little trick that we're going to apply, which is to make it so that everything fits into the camera. So to do that, first we need to go back into our code and we need to get another public reference, which is just going to be a game object. We actually want the renderer. So you could get the renderer if you were doing things this way, but you're probably not going to be doing things this way. So I'm making it a game object so that you can easily adapt this to suit whatever you're doing. So game object, we're going to call it item, because it's just the item that we're making an icon for. And then we want to do this near the top because this needs to happen before we grab our texture down here. So it just needs to be above this part really, but I'm going to do it up here. And what we're going to say is cam.orthographic size equals item.getComponent. So this is the part where we get the renderer. Renderer.bounds.extents.y, and then we're just going to add 0.1f. So what's happening here is basically the orthographic size, the zoom level of an orthographic camera. I think in Unity it kind of works like it's basically the height, I think. So the higher that number, the further away you are, because it's fitting more screening. So as long as the item is directly in front of the camera and it's not lower than the camera, this will zoom the camera out so that it fits it all in the screen. And of course, this also assumes that the item is roughly square. So that's something you'll have to factor in. So if we go back to here now, I'm just going to make this a little bit darker. It just looks white when there's an icon there. So if we go back to our canvas and we grab that, and then we want to drop our test block into here. And if we press play, hopefully it will have zoomed out a bit. There we go. And if I go to here and I fly this back over here, you'll see it shouldn't make a difference because it's an orthographic camera and it's basing its size on the height above the item. You could apply a material that is not affected by light onto your item, which might be a bit messy, or I guess you could actually just drop a light in there. So put this back at 10, and then if we create a spotlight in our camera, this is a bit of a hacky way to do it, to be honest, but let's just do it for the sake of it. For now that I've started, I'll finish. I'll just turn that up there and then press play. We should have less shadow on our item. The problem with this is that it's going to be, if you have an item that's a lot larger, it's going to get hit differently by the light. So that's something to play around with. Like I say, you can always switch the material on the item to unlit. So if we were to go have a look at this here, if we changed this to unlit texture, you can see light's no longer affecting it. So if we'll do that before we actually draw the texture, that should work. Yeah, as you can see, it almost gives it a cartoon appearance now, which is nice. Yeah, so that's pretty much it. And then if we just do a little test, hopefully if I mess around with the screen size, it shouldn't affect our image. So that is that. You will notice that it has got slightly jagged edge. I might actually be able to zoom in there. You know, it's got these slightly jagged edges. That is unfortunately a problem with the way Unity rescales sprites. There is some free code out there on the Unity wiki about how to resize sprites smoothly. I'll drop a link to that in the description, but basically what you would do is you would insert this function in between creating your texture and passing it out to the sprite, and this can basically resize it, but in a nicer way than Unity does by default. And also you would have the advantage that this technically, this image here, this sprite, is the size of the screen, so it's not quite 1920 by 1200, but it's not far off. So Unity is resizing it down to the size of this icon. So anyway, that is it for this video. I hope you enjoyed it. I do quite like doing these little one-off type things, and they are a lot easier to make. So yeah, all that's left to do is to thank all my amazing Patreons, all the people who've been very patient in Discord, because I have been absolutely nowhere this last couple of weeks. I've just been very busy. So thank you guys for keeping things ticking over in there. Thank you everyone who is supporting me on Patreon. Especially thank you to the Sugar Daddy / Mama tier people, and that is Dave Maldine, Reg Reed, Gabrielle White, Julio Montero, Aaron Clark, Mr. Drunken Dragon, and welcome aboard Calvin Hurst. So thank you guys, and thank you everyone in the Discord. Thank you everyone who likes, subscribes, everyone who rings the bell thing and tells your friends and whatever else you do. That's it. I'll see you next time. Bye bye.